Then, we started with, we're going to recap for our video here, then we're restarting. We started with the definition of a polynomial, and we said a polynomial is any function that has an exponent that's a positive number. And then the degree of that polynomial equals the biggest exponent. So we put them in general form, which meant we lined them up from the biggest exponent to the smallest exponent. And then we look at that biggest exponent and we say, oh, well that's degree, like in our first example, 5. Bless you. So that degree then tells us the number of zeros or answers that we're going to have for that function. Or how many times it crosses the x-axis. Okay? So we'll look at a couple more in just a minute. But there are several ways that we can find our zeros or our answers for our problems. One of them is to graph it and use our trace function on our calculator and see where it crosses that axis. A second way is to look at a table, so we can put in our calculator and then look at the table and find out where the places. On our table, we're looking for the places where y equals 0. So what is the x value when y equals 0? Because think about our graph. If it looked like that, it's here. Where y equals 0, what is x? Y equals 0, what is x? Y equals 0, what is x? Some of them we can factor and set equal to 0. That was how we learned how to do it in Algebra 1, our one way we could do things. And we'll talk a little bit about factoring here in a minute. And the fourth way that we probably won't get to until tomorrow is to use the quadratic formula. But how many of you are already in physics? Anybody? A couple of you? So do you have the quadratic formula already programmed in your calculator? Yeah. So you're like a step ahead of the game if you wanted to use your quadratic formula in your calculator.
Great.
So as an example, if you have something that's already factored, so these are already a set of factored pairs, two little expressions there inside our parentheses, you could take each one of those and set them equal to 0, and then just solve. So this is an example of doing it like number 3 up here, factoring them and setting them equal to 0. Well, they're already factored for us, so that saves us a step. And we can just set it equal to 0. When we do that, to solve over here, I'd add 5.6 to each side, which would just give me x equals 5.6. And to solve over here, I'd subtract 3.1 from both sides, which would just give me x equals negative 3.1. Some of you who are extra observant are just going to say, well, can't I just switch the sign and say this is 5.6 and this is negative 3.1? Sure. Same thing.
What is that set equals to 0?
Set equal to 0. So you're factoring and setting, let's see, set equal, there we should put the on there better. So we're going to factor and then we're going to set them equal to 0. Alright, so the last two little pieces of information on there then are the maximum point and the minimum point. The maximum point is going to be the biggest value on your graph, and the minimum point is going to be the smallest value that you have on your graph. So let's take a minute and look at a couple that are like the ones from our assignment we're going to start here in a minute. Let's do, sorry about that, a little bit of review. So, for example, one of the problems we're going to look at today says x to the third plus 9x squared plus 26x plus 24. And they want to know what's the degree of that polynomial. It's just degree 3. So those are pretty easy, right?
Mm-hmm.
What if they had given it to you like this?
You can see.
I'm sorry, I'll move it up in a second. What if they had given it to you in that order? The degree of that polynomial would be?
Degree. Isn't it the biggest one?
It's always the biggest number. So it would be 3. It's always the biggest number. And notice, all I did was move these two around. Otherwise, the polynomial is exactly the same. If you put it in your calculator, it would graph exactly the same. This one is in general form because I have the biggest exponent first and then I'm descending. This one is not in general form. So if they asked me to put it in general form, I'd have to switch those two places. Let's see. What else we got going here? Where's it go? The only other thing that we're going to do today that we haven't done since freshman year probably is factoring. So just for some good review real quickly before we send you some problems, they're going to ask you to do things like factor x squared minus 10x plus 25. Is there anybody who thinks they can remember their freshman year? Not at all. So, if I can't remember my freshman year, I might not be able to remember how to factor. So let's run through the steps kind of together here and see how we do. So the first thing we have to do to factor is remember the factor means we want it to be in parentheses like that. So, when we are factoring, the first thing that we're going to do is split up the first number. And the truth is, factoring works great for things that are x squareds and not so great for things that are not. So if you end up with an x cubed function, I would graph it and use my table. Okay? And even for this function, if I couldn't remember how to factor, I could graph it and either look at the graph or look at my table as well. But for now, we're going to just practice one through here. So if I split up my first number, the only thing I have there is x squared. So I'm going to put 1x in each of my brackets there. So I split up the first number. Step 1. Step 2. Then I need to look at my last number. And when I look at that last number, I'm looking for multiples of the number. Or in other words, what can I multiply to give me 25? Well, the only thing that comes to my mind for 25 is what? 5 and 5, right? So, I would try it. I'm going to try it in pencil just in case it's wrong. If I put a 5 and a 5 here, 5 times 5 is going to give me 25, yes?
Yes.
Absolutely. But I need to somehow add those two numbers up, because this is add, and give me negative 10. Can I add 5 and 5 and get negative 10?
Mm-hmm.
If they were negative 5s, I could, right?
Yeah.
So that just means that I need to put a negative sign here and here. So I split up my first number, then I looked for my multiples, then I'm going to plug those in. And I'm going to see if they add up to my middle number. If add, there we go. can I get them to add up to my middle number? In this case, I could, because if I made those both negative, that would get me negative 10 here. What's negative 5 times negative 5? Positive 25, right? So that works out there. And so then I have both of my answers here. I could, if they were asking me to, set them equal to 0 and add 5 on both sides and get x equals 5. But this one is x equals 5 and so is that one, so I'm not really going to do them both because I don't have that much energy this morning. But it would definitely give us the opportunity to factor and then solve. So we are going to do just a few of those. Just try to practice a little bit more as well. And we are going to do a few like the first ones. So let's start on, in our books, we're going to start here on page, we got to find it first. Oh, we're cooking now. 364, because we skipped chapter 5 or 6, because we don't need to do that one. And on 364, we're going to do number 1. We're going to do number 2. We're going to do, let's just do 2A and B. We're going to do number 10 and 11. And we're going to try 14. So let's start with those on that page. And then we're going to look at page 373. And on 373, we're going to do number 3, number 4, and number 5. And I think that's plenty of work for today. So let's just do those. Page 364.